Hey guys, it's Derek. Today we're going to be looking at the first of two practice exams for the AWS Certified Cloud Practitioner test. And the goal of doing this is a few things. Number one, obviously, we want to kind of go through each question and talk more about what the answer is so that you fully understand, what's going on. And we also, just in general, want to look at how we can actually apply certain test-taking strategies to the test. There's a few sort of different strategies you can utilize for just general test-taking tips for each AWS exam, this one included. And then additionally, we're going to look at, how to actually kind of read and go through documentation. Whenever you use an AWS, or any cloud provider, at some point you're going to use documentation. It's inevitable. So that's why, or one of the reasons why I like AWS so much, because their documentation is very clear and concise. So having said that, let's go ahead and jump right into this. If you haven't taken this test yet, one thing you'll notice is that, obviously the questions are going to be in a different order than, here versus when you're actually taking the test. And, if you want to just pause the video for a few seconds before, we actually get to the answer of each question so you can answer it again. If you've already maybe taken it, something like that, be my guest. So use this video however you want, and hopefully it's helpful. All right, so let's get into it with the first question. So under the shared responsibility model, which of the following would be the responsibility of AWS? All right, so the keywords here are the shared responsibility model and the responsibility of AWS. So what that tells me is that we're going to be looking for some kind of answer that involves, maintaining or provisioning, the actual physical hardware in the data centers. So let's take a look. So patching application software running on EC2 instances. That one is not going to be correct because the customer is responsible for, maintaining the application software that's actually running. Securing network access to your AWS resources. Again, this is going to be the customer's responsibility to ensure, you have the proper firewall, security groups, NACLs, things of that nature in place. Ensuring the physical hardware in an availability zone is running properly. This sounds good because, again, we are talking about the actual physical hardware that's being used. So I'll select that one for now. And ensuring customer data is encrypted at server level. Looks like it actually shows us the answer there, so just ignore that. We actually won't do that again. But again, ensuring customer data is encrypted at server level. It's again up to you as the customer to properly encrypt, your data at a server level, whether it's, an S3 or a database, something along those lines. So the correct answer here is going to be C. So the AWS shared responsibility model can be thought of as follows. AWS is responsible for the security of the cloud, and the customer is responsible for security in the cloud. In other words, AWS handles the actual physical hardware that makes up the cloud, and how you use it and secure it is really up to you. So if we take a look here at this linked documentation, it'll take us to the shared responsibility model. And this infographic right here, if you don't necessarily want to read everything in detail, this is just kind of a good image to try to remember. Again, the actual physical hardware here is the responsibility of AWS. And when it says software, this isn't talking about your application software. This is talking about the software that you use to provision AWS resources like EC2, RDS, Elasticache, things of that nature. So that's what AWS is responsible for. But everything else that actually relates to, the operations of the resources you provision and your application itself, that's going to be on you. All right. So that's the first one there. All right, number two, which AWS service would be used to support SQL-like databases? EC2, that's not correct. That's going to be the main service for compute workloads. S3, that's also not correct. That's going to be for object-level storage, not SQL databases. RDS, I'm going to go with this one because RDS stands for Relational Database Service. So that's going to be the answer I pick. And then finally, DynamoDB. This is a NoSQL-like key value database storage service that you can use. So we're going to go with RDS. And that is indeed the correct answer. So it's the primary database service from AWS that supports SQL-like databases, such as like PostgreSQL, MySQL, Oracle Database, Microsoft SQL Server, all the kind of standard SQL databases you would actually kind of see or use. And then we have a link to the main page for RDS here that you can go look at if you would like. The incorrect answer, so again, EC2 is the primary compute service. S3 is for object storage, right? Storage is going to be different than database. Remember that. This is object storage. And DynamoDB is that NoSQL database, so RDS is the correct answer here. All right. Next question. Which of the following AWS services would be used to directly support containers? So the question is saying directly support containers. So we're going to be looking at, there's a few different AWS services that, again, apply to containers, whether they're Docker or otherwise. So let's see if we can pick out a couple of those. AWS ECS, that one I know stands for Elastic Container Service, so we're definitely going to choose that one. AWS EKS, which is Elastic Kubernetes Service. That is the service for running Kubernetes, which is a container orchestration service, so we'll select that one as well. Athena is not correct. That is a SQL-like serverless tool to query your data, particularly the data that's stored in S3. Elastic Beanstalk. So this is where it gets a little confusing, although Beanstalk can... Beanstalk is basically a service that allows you to run an application hands-off, and while it can utilize containers, this service isn't specifically designed to support containers. So that one's not correct. And finally, AWS Lambda, that is a serverless compute service that, again, does not involve containers. So the correct answer is going to be ECS and EKS. So if we come here, yep, ECS and EKS. So ECS is used to deploy, manage, and scale containerized applications. EKS is compatible with Kubernetes, which is a software that allows you to orchestrate, schedule, and scale Docker containers. So as you might have noticed, Docker is huge. It's the primary container service, at least for now. But there are a few others. If you go to the ECS documentation here, that you can get support for. And again, Athena is for analytics, and like I said, Elastic Beanstalk is designed specifically to support containers, and then Lambda is that serverless compute service. So that is your answer there. And moving on to the next question. You have a client that has been running some compute workloads using EC2 instances. They recently have been concerned with the costs that they are incurring from using on-demand instances. Knowing that their workloads can tolerate interruptions, which of the following instance purchasing options would you recommend to help them most reduce costs? All right, so this is kind of the first longer question that we've gotten. And some of the keywords here that I'm really honing in on is that they are concerned with, okay, it doesn't like that. All right, we just won't highlight anything. So they are concerned with costs, and their workloads can tolerate interruptions, and which would you recommend to help them most reduce costs? So this question is really getting after, what's the most cost effective or efficient option here. Again, knowing that workloads of EC2 instances can tolerate interruptions. So whenever you see this, knowing that their workloads can tolerate interruptions or something along those lines, you should right away be thinking of spot instances. It's up to a 90% more or less savings potentially on regular on-demand EC2 instances. So whenever you have workloads that, again, can be interrupted, no problem, you want to start thinking of spot instances. Okay. So reserved instances, that will help you save money, but it's not going to be as cheap as spot instances. And dedicated hosts, it's not really going to save you money at all. That is, getting your own physical server that you can kind of customize if you need to, if you have like governments or specific compliance requirements or licensing requirements, something like that. And on-demand instances are not the cheapest option in this case because spot instances are much cheaper. So when we come here, you can indeed see that spot instances is the correct answer. And again, you can see that you can get up to 90% savings when you compare them to spot on-demand instances, which it said they were using now. So if we go here to the spot instances documentation, you can see, it kind of gives you an example here of, what you can expect to pay for a certain type of EC2 instance if you're using a spot instance, and the percentage savings compared to running the same instance but on demand as opposed to spot. There's definitely pros and cons to spot instances. For example, one of the cons is that obviously your workloads can be interrupted if let's see if I get this right. So if the spot price exceeds what you are currently paying for your spot instance, then AWS will take their instance back because somebody else is going to pay for it. If I remember that right, it's somewhere in here. It's kind of in here. There's also more documentation on spot instances if you want to find that specifically. But anyways, the bottom line is that on-demand instances for EC2 are going to be substantially cheaper spot instances are going to be substantially cheaper than on-demand instances, so keep that in mind. Okay, and we already kind of went over the other ones. Dedicated host, not going to save you any money. Reserved can, but not as much as spot. Then on-demand is not the cheapest option. All right, so moving on. Which AWS offering allows you to find, buy, and immediately start using third-party software solutions over your AWS resources? So the keyword here is that it says AWS Offering as opposed to AWS Service. And you want to start using third-party software. So that right off the bat says to me that this is going to be an answer that is not necessarily an AWS service. Otherwise, it wouldn't be third-party software. So the only one here that matches that criteria is AWS Marketplace. And, I know off the top of my head that the Marketplace is, in fact, where you're able to buy and, run third-party applications or software on your existing AWS resources. So if we look here, yep, that is correct. And then AWS Config, CloudWatch, and Direct Connect are all services that do various things. So there's links to the documentation if you want to look at that. Okay. So next question. A customer is concerned that the servers being used for their AWS resources will not be in compliance with the region they want to expand to. Which AWS service gives you the ability to view and download compliance-related information for free? All right, so the keywords here are view and download compliance-related information for free. And whenever I see that, I automatically start thinking of Artifact because Artifact is a portal that you can sign into using just your regular AWS account. It doesn't cost you any money to download these reports or to access the portal, which is great. So if you are expanding to a new region like the question suggests, then you will have no issues if like the government or specific industry sector you're in needs specific compliance requirements on the hardware that's being used. AWS takes care of that for you. That's definitely one of the value-added propositions of the cloud as well. So let's look at the answers here. Amazon Inspector, that's not going to be correct. That's going to inspect workloads. That doesn't have anything to do with compliance-related information. GuardDuty is a service to secure your AWS accounts against malicious activity. Application Firewall, WAF, is a firewall for web applications. And finally, Artifact is, again, that portal for compliance-related information. So if we look at the answer here, it is indeed Artifact. So it's a free service. And, it includes things like accreditations, auditor-issued reports, third-party attestations. I might not have pronounced that right, but that's what I'm going with. And then, again, Inspector, it monitors your workloads. Guard Duty monitors your accounts. WAF monitors your web apps. All right, so that's that one. Moving on, which of the following is a benefit of using the AWS Cloud that can add value to your business? So stop guessing capacity. That's correct because with what guessing capacity means is that if you were, for example, to have your resources and your servers on premise, you have to buy your own servers, so you have to guess how much physical servers you're going to need to meet your business requirements. With the cloud, you don't have to do that because you can scale up or down with the amount of resources and servers you have available. Increased agility, again, also very true. You can set up new servers in minutes in the cloud, whereas, again, good luck setting up brand new servers in minutes on premise. It's just not going to happen. Go global in minutes, same concept. What's faster, set up a server just on another continent or just do it in a few minutes with AWS? Pretty obvious answer there. So I'm thinking we're going to go with all of the above. And that is the answer. And there's actually a few different advantages to cloud computing. If we come in here, we can see, what the rest of the advantages are that didn't get mentioned in the question, but there's quite a few, which is why, at least some of every business, I believe, should be in the cloud. And that's, again, part of AWS's value add proposition in the cloud. So there's that. All right, moving on. A customer comes to you concerned about the security protocols in place. They'd like to add an additional layer of login security to their users' AWS Management Console. How would you accomplish this? So the keywords here is they want login security. So security at the layer of users actually logging into the AWS console. So we could enable AWS CloudTrail. Well, that wouldn't actually add security. It would just kind of tell us what actually happened. So it's not really making things secure. It's just kind of helping us figure out what actually happened after something happens. Enable multi-factor authentication, MFA. This is definitely thinking correct because what this is when you go to log into your account in the AWS Management Console. What it's going to do is once you log in with your username and password, it's going to send you a code to maybe your cell phone or your email that you have to go and then enter within it's either 30 or 60 seconds. And again, that makes it very hard for someone to break into your account because the code goes to your device that you have on you and it expires in a minute or less. So I'm thinking MFA is the correct answer. Audit AWS IAM roles. Again, this would be helpful in securing access to your, it would be helpful with, managing the access that each user has to your AWS resources, but it's not actually going to help login security. And create and apply a certificate using the AWS Certificate Manager, ACM. That's also not going to be helpful with logging in. That's just going to enable, an SSL TLS certificate. It's going to help encrypt your data in transit, which is helpful, but not for login security. So if we look at the answer here, enable MFA. So you need to log in with your ID and password and then provide the code that goes to your device. So AWS has a nice page here about kind of what MFA is and how, more details about it, kind of how to enable it. So definitely check that out. Again, CloudTrail is a service that just tracks activity, but it won't, actually provide proactive security. It's more reactive. Again, IAM roles. Sure, it's helpful, but it's not going to help with login security. And then ACM, just going to give you a certificate, but doesn't have anything to do with login security. So yeah, enable MFA is the answer to that one. All right, next question. Which of the following is not a type of cloud deployment model? Hybrid, on-premise, cloud native, or public? So hybrid is a model. It's when you have some of your resources on-premise, some of them are in the cloud, whether it's AWS, Azure, whatever. On-premise is everything is, physically on-premise at your business or some, data center that you own. And the cloud native is the opposite, where all your resources, all your servers, everything is in the cloud. And public is not a type of cloud deployment model. So that is going to be the answer there. And if we look here, you can see each of the different deployment models, cloud, hybrid, on-prem, and then some more information about both. So there's that. Which of the following services allows you to set up a direct physical connection between your on-prem resources and the cloud, completely bypassing the public internet? All right, so let's see. CloudFront. CloudFront is a service that allows you to cache content closer to your end users, but because they're retrieving content from these caches using the internet, that doesn't bypass the public internet at all. And again, it has nothing to do with connecting your on-prem resources in AWS Cloud. VPC is the virtual private cloud. And basically what it is, it's a logically isolated section in the cloud where you can set up resources. But it's not necessarily, in and of itself, a service to connect your on-prem resources with the cloud. It's just a service used to set up resources in the cloud. So that's not correct. S3 is object storage, so that's definitely not correct. So that leaves us with Direct Connect, which is the correct answer. And Direct Connect is basically a service that gives you a physical low latency connection between your on-premise resources and the AWS cloud by, again, having actual cables go to a data center that's hosting, part of the AWS cloud and some AWS servers. You can read more about that here at the Direct Connect documentation. So again, you have your kind of on-prem resources here. So this was saying if you had like your office resources and your own data center, you could connect them both. And then these lines right here would represent physical cables, and then it just connects to a data center that AWS has within a given region. So that is Direct Connect for you. And again, CloudFront, content caching delivery service, not for connecting on-prem to the cloud. VPC sets up resources in the cloud, and S3 is a object storage service, so those are not correct. All right. Next question here. A company comes to you asking what the cost would look like to start using the cloud. They have an idea of the resources they would need to provision to meet their needs. Which of the following AWS services would allow them to estimate the cost it would take to set up this cloud architecture? All right, so the keywords here are that, they are asking about the costs of, beginning to use the cloud, which means that they are not in the cloud yet. So they have an idea of the resources they would need to provision. So that means they have an idea of, the compute database resources, etc. that they actually need to set up. And which one will allow them to estimate the cost? So let's go through the answers here. AWS Cost Explorer. This is going to be a way to kind of look at what your existing AWS resources are costing you. It's not going to be a way to estimate, what setting up different types of resources would actually, how much that would actually cost. So that's not correct. Budgets is, it almost sounds correct, but budgets is more of a service to, within your AWS account, once you're actually using services, it's a way to control your costs and keep them under a certain amount and alert you to, potentially going over say your allocated amount for your compute resources, for example, and then trigger actions to automatically deal with that. So that's not correct. AWS pricing calculator. That sounds correct to me. Basically what this is it allows you to pick from pretty much any combination of AWS services and put them all together and see what that would come out to, roughly, for a total estimate of cost. And SDKs are software development kits. They don't have anything to do with cost, so those are definitely not correct. So I'm thinking pricing calculator here. And that is the correct answer. So again, it's a free tool that lets you combine resources so you can get an idea of what they would cost on a monthly or yearly basis. So if we have a pricing calculator here, you don't even need to sign in to your AWS account to look at this. You could just choose a region. So we'll just say US East Ohio, and then let's just say we wanted to look at some EC2 instances. If we come here, you can configure, you see it down here for what it already set it as. The upfront cost will be this, monthly cost will be this. But if I were to come in here and say, and maybe instead of this instance type, maybe I wanted to, use this one instead. And that would leave me at a more expensive instance here, or more expensive total upfront cost. And what you could do is you could come down here and play around with, in the case of EC2 anyways, different types of payment plans. So if you reserve, your instances for more time, just all up front, then you can save some money if you just pay all up front. Or if you do, partial up front, you pay a partial amount up front and then a total monthly cost. So if you, again, do no upfront, it's going to be slightly more per month, but obviously you don't do anything upfront, which is nice if, you're maybe experimenting. So that's the pricing calculator. You can come in here and play around with that as much as you would want. But yeah, that's the way to estimate costs in the cloud. All right, so next question. Where can you find information about prohibited actions on the AWS infrastructure? The AWS Acceptable Use Policy, that sounds right to me, although it's already checked for some reason. So that is indeed the correct answer. The billing console is just where you see, your costs and kind of handle those. Trusted Advisor scans your environment for a few different areas to let you know recommendations according to AWS best practices about what you could do to improve the state of your architecture and your resources. And SLAs are software licensing agreements, and basically these are, let's call them documents that outline exactly what you can expect when you're using, AWS services. So for example, you can expect availability of your S3 data at 99.999999% of the time, so 8 nines if I remember correct, and that's in their SLA. So we're going to go with Acceptable Use Policy, and that is the one. And you can even see a copy here of the Acceptable Use Policy, and then get more questions from AWS Support there if you need to. So there's that. Moving on here. Which of the following is not a part of the AWS global infrastructure? Regions, edge locations, on-premise data centers, availability zones. I know off the top of my head, if you're using on-premise data centers, you're not using the cloud, so that has to be the answer. And regions, availability zones, and edge locations are in fact parts of the infrastructure. So yep, on-premise data centers. Again, if you're using on-premise, you're not even using the cloud, so there's no way it can be part of AWS's global infrastructure. All right. Which of the following key components in enabling a system to monitor your AWS resources and then notify you when events occur? So we select two. So we want to basically put two services together to enable a system to monitor resources and then send notifications. So Amazon SNS, this stands for Simple Notification Service. So I'm pretty confident that this is going to be one of them because we need to be notified when events occur. So I'm going to select that one. Route 53, this is a service that's used to handle domain name resolution and DNS services. but it doesn't have anything to do with notifications or monitoring. CloudWatch, this definitely monitors your AWS resources. That is, in fact, its sole purpose. And then it can work with SNS to trigger events or to trigger actions based on events. So I'm going to go with CloudWatch and SNS, but let's just go with the other two. Aurora is Amazon's database. It's a service that represents, if I remember right, PostgreSQL or MySQL databases, but it's serverless, so it's pretty cool, but it doesn't have to do with monitoring and notifying. And then Cognito, this manages or handles the authentication of third-party logins. So if you were to try logging into your AWS account with maybe a Google login or an Apple login, something like that, you can do that in Cognito. But here, I'm going to go with SNS and CloudWatch. So, yep, SNS and CloudWatch. And you can even see here they have some documentation on how to use them together to do this exact thing. So, pretty neat there. But just know that SNS and CloudWatch go hand in hand when it comes to monitoring your architecture and notifying you of specific states of your architecture events. So that's that question. So let's see, next question here. What is the main benefit of trading capital expenditures, CapEx, for operational expenditures, OpEx? It provides a much more secured solution. You don't know about this one because you can secure both of these, so I wouldn't pick that. Replaces large fixed upfront costs with variable costs down the road. I would definitely lean towards that because it's kind of the whole purpose of it, right? Because capital expenditures, you have to spend money up front buying like your own servers, hardware, facilities, whatever. Whereas operational expenditures, you just kind of use them as your business operates, right? You pay as you go. So I'm going to lean towards that one. I'll give you a localized set of servers you can customize. Again, this is kind of capital expenditures because you're getting your own servers. Provides the ability to deploy resources globally faster. Definitely not because, if you want to set up your own servers, then good luck doing that very quickly all over the globe, unless you're like a huge corporation. So I'm going to go with B here. Let's see. Yep, B. So, with CapEx, you need to guess how much you need up front and then buy all those servers and do all the work it takes to maintain them. But with OpEx, you can outsource all of that to AWS and then just pay as you go. So one of the huge advantages of using cloud computing, and again, we can see the same advantages of cloud computing that's listed in here. Trade fixed capital for variable operational. So there you go. All right, moving on here. As a system admin, what service could you use to identify the user that made an API call to terminate an EC2 instance? So the key kind of phrase here is identify the user that made an API call. And the specific service that traces API calls and API activity in your account is CloudTrail. So that's what I'm leaning towards. Let's see if that's an option. CloudWatch. CloudWatch is more to monitor kind of the state of your resources and architecture and events. It's not necessarily made to trace API calls. CloudTrail, yep, I'm going with CloudTrail. Redshift is a data warehousing solution, or service rather, so not going to really have to do with identifying API calls. And Systems Manager is kind of a centralized hub to manage some of your resources. So again, it's not for identifying and tracing API calls. So we're going to go with CloudTrail. Yep. So if we look at the CloudTrail page here, we can see that it records user activity and API usage in your services. So there's a few different ways that you can look at, or a few different sources rather, that you can get your API records from, and then you can store them and analyze them later on if you want. So that's CloudTrail for you. And if we look at the next question here, which of the following is not true in regards to decoupled and monolithic architectures? Okay, so which of the following is not true? So decoupled architecture gives you a higher degree of fault tolerance. That is true because you have multiple components doing their own thing as opposed to everything kind of relying on the same single server or resource. It's easier to implement changes on a monolithic architecture. I'm not sure about that because when all of your services are working together kind of on the same resource with a bunch of processes running under the same service, then if you introduce something, it could potentially just break everything if it doesn't work right. So I'm leaning towards this one. A decoupled architecture means that your application has, we're going to come back to that one because I think when I click on it, it's going to tell us the answer. Decoupled components give you a much greater ability to customize your architecture. That seems true to me because again, you can just say you had like a compute and a database component, each separate from each other. You could apply changes and customize one and not really directly affect the other. And then decoupled architecture means that your application has different components, each with its own specialized or specific job. Yeah, so that is definitely true. It's kind of weird having to read it kind of like that. But yeah, so decoupled architecture, again, to go back to what I was just saying, if you had like a database and a compute component, they're each doing their own job, right? The database is handling your databases and the compute is handling your compute workloads. So it's great because again, they can handle failure on their own. They aren't gonna crash the other if one goes down. You can recover you can recover one easier if it goes down. It's not gonna just blow everything up. So it's definitely not easier to implement changes on a monolithic architecture. So that is the correct answer there. So theoretically, it might seem like it'd be easier since you only have one server. You could just put everything on there. But again, if you introduce maybe you're experimenting with a new feature or whatever, if you introduce breaking changes, there's no way to know what's going to be affected or not because everything is codependent on each other because it's so tightly coupled. And if something does happen, that could affect everything else since again, it lives on the same service or the same resource. So it's kind of called microservices. I call them components, but microservices, components, tomato, whatever. Same thing, but here's AWS's kind of spiel on monolithic versus microservices. So if you want to read into that, there's that. But just know that in general, use decoupled components or microservices. It's definitely the way to go. It's kind of what AWS is built around anyways because they have a different service for databases, different service for storage, for machine learning, analytics, whatever. So always lean towards decoupled. All right. Which of the following is the best description of what AWS Elastic Load Balancer is used for? So which of the following is the best description? Basically, just define Elastic Load Balancer. So used to handle domain name system routing, that's going to be Route 53, so that's not correct. Automatically add or remove EC2 instances as needed, that's also not correct, this could be auto-scaling. Automatically distribute incoming application traffic across multiple targets. That sounds like load balancer. And then object storage that can be attached to EC2 instances, that's going to be EBS, Elastic Block Storage. So we're going to go with C here. All right. Let's take a look at why. So there's three types of load balancers. And again, the whole point of a load balancer is to distribute traffic. So you can have an app load balancer that works with basically the HTTP and S layer designed for your applications, right? Hence the name, application load balancer. Network load balancers are for TCP, UDP traffic and extremely low latency. If you ever see, extremely low latency being a requirement, generally lean towards network load balancer. And the gateway load balancer also supports TCP, UDP traffic, and it's designed to handle and check the health of virtual appliances But it's again not super popular. It's kind of a specialized use case. You're going to mostly see app and network load balancers. And then, yeah, here's some documentation on each of the wrong answers there if you want to look at that. So here's that one. All right, moving on. Your system admin has grown tired of having to assign permissions to each individual IAM user. Which of the following could you suggest they do to alleviate this issue with the least amount of effort? Let's see, they could create IAM groups, give each group specific permissions, and assign users to the appropriate group. That sounds right because you only have to manage the groups. You don't have to manage each individual user. So that sounds like it would definitely take less effort, right? Because we're looking for the least amount of effort. Create an AWS organization and enable appropriate service control policies. So SCPs don't actually apply to a user level. It's going to apply more at an account level, the accounts within your organization, and it's going to kind of define what they are able to do. So that one's not correct. Create IAM roles and assign them to each user. Yes, this would work, but it definitely is not the least amount of effort because, if you had 200 IAM users, you don't want to have to go through and maintain all of those users. It'd be a lot easier to just maintain the groups. And then change your default IAM behavior to give new users admin permissions so they can do whatever they need. That's a horrible idea. Don't ever do that. Don't ever do that. There's an AWS principle called the principle of least privilege. And basically what that means is, just give a user just enough permissions to do their job and nothing else so there's no accidental problems or intentional problems. So yeah, we're going with create IAM groups and then manage the groups. So, yep, we're just going to manage groups. And then here's some documentation about managing groups. You can feel free to look at that. Okay. So moving on, your company has decided that they would like to start a plan with AWS Support. All right, so we're looking at support plans. Because there are some production workloads being run in AWS, which support plan is the most cost efficient to allow you 24/7 phone chat and web access to cloud support engineers. So if I remember right, this is going to be business. The basic just gives you email support about billing questions. It's included with every AWS account, but it's not really super helpful. Developer gets you access, but it's not 24/7 access. Business does get that, and so does enterprise. However, we want the most cost-efficient option, and enterprise is definitely going to be the most expensive. So I'm going to go with business, and yep, it's business. So yeah, basic. So only questions about billing. Developer level support, you don't get 24/7 access. And then enterprise do, but it's not the most cost efficient. So if we come here, we can see the different support plans. Basic's not really listed because again, its only rather feature is email support for billing questions. But as you can see, developer, you can only have access during business hours. And starting a business up, you can have 24/7 access. So that is the answer there. All right. Which benefit of using the cloud involves saving money due to large amounts of AWS customers using the same hardware, high availability. High availability doesn't necessarily isn't necessarily this definition. What that basically means is that it's available when you need it, and it's not out of commission or experiencing outages. So that's not correct. Economy of scale. This actually is the definition of what's going on here, and again, because you have thousands or hundreds of thousands potentially or more customers over time using the same AWS server, they can afford to offer it so cheap because there's so many people just paying for it. All right, pay-as-you-go pricing. This is a pricing model that does help you save money, but it's not necessarily the benefit that pertains to many people using the same server. And then global reach, that just means that you can use or you can have servers wherever you want in the world, but again, doesn't involve saving money. So we're going to go with economy of scale. And yep, economy of scale. And again, we're going to be linked to the benefits of cloud computing. One of those is benefit from massive economies of scale. So there you go. All right. So next question. Which of the following best describes the relationship between regions and availability zones? If you're going to answer this one, go ahead and pause it now because it looks like I need to click on these to see it. And again, it's going to reveal the answer. So I'll give you the chance to pause it now if you want. All right. So you had your chance. Let's look now at what it's going to be. So each region is completely independent and each availability zone is isolated, but the availability zones in a region are connected through low latency links. Yep, that sounds about right to me. Each region is completely independent and availability zones are never isolated. That part right there is not true, so we don't even need to read the rest. Each region may be dependent on another region. That is also not true. Each region is independent. And for the same reason, this answer is incorrect. So yeah, this is the only correct answer up here. And if we look here, we can see what the global infrastructure actually looks like. You've got regions, availability zones, and then edge locations are just basically caching sites for CloudFront and DynamoDB accelerator tables. So there's that. But yeah, they're all independent. I mean, that's kind of one of the value adds of cloud computing is that, if something were to happen to an availability zone or region, you still have the other ones completely available to use. All right. Autoscaling provides which of the following benefits to your application? Your app can be reached by a global audience. Yeah, that's not really what autoscaling is for. The purpose of autoscaling is to automatically add or reduce the amount of resources that you have, in use, so that you can continue to meet demand and performance requirements. You can better control who has access to your application. That's related to security. That's not what autoscaling does. Your application gains better fault tolerance. Yeah, I mean, that's definitely true because, if you, say you have an application or a resource that goes down, you could add more services to help it be more fault tolerant. However, it won't stop your resources from actually running into issues, so I don't believe that's the correct answer. And your application could save the most money possible. I'm leaning more towards this because, like I said earlier, if you suddenly have a reduction in demand, you don't need to have all these resources hanging around anymore, paying for them, so you can just automatically reduce them. So I'm going to lean towards this one. Your application can save the most money possible. Let's take a look here. Oh, interesting. Your application gains better fault tolerance. So the primary purpose of autoscaling is to ensure you have the correct number of instances running to meet your application performance requirements, right? By setting up autoscaling, if something were to fail, you can have another one automatically started, causing little to no impacts on your application's operation. Let's see why this one isn't correct. We know why these two aren't correct. So let's see what this one says. So it can save you money by terminating instances that are not being used, but this is not the main purpose of autoscaling. Yeah, that's true. That makes sense. So autoscaling itself, if you just eliminate everything else that it's related to and just look at the autoscaling service itself, it is meant to ensure you have the correct number of instances, because what you'll end up doing is you're going to set a minimum, maximum, and desired number of instances. And autoscaling is less concerned about, how much you're spending and more concerned about just meeting your desired amount of instances if possible, or not going below or above the minimum or maximum. So yeah, that makes sense that that's the answer there. All right. Hey, sometimes you get one wrong. It's the way it goes. Which of the following is specifically an AWS best practice for security? Applying the principle of least privilege, that's security 101. I kind of mentioned it earlier. You only give people enough permissions to do what they need to do and nothing else. Applying the principle of mechanical sympathy, that basically means using something how it's supposed to be used. So, for example, you're not using like an EC2 instance as a database because that's not really how it's designed to be used. Eliminate single points of failure. That doesn't have to do with security. And democratize advanced technologies. That additionally does not have to do with security. So let's go ahead and go with applying the principle of least privilege. And that is the answer. So if we come here, we have a blog about AWS security best practices. And you can read through that. Security of multiple layers, control access, basically, reduce the probability of accidents or infiltrations happening. All right, simple but not easy. All right, next question. Under the shared responsibility model, which of the following are the responsibility of the customer? So again, AWS is going to be responsible for physical hardware and the services they provide as software, so EC2, S3, whatever. Anything else is going to be on the customer, so let's see what falls in those categories. So patching physical servers, that sounds like AWS. Data center security also sounds like AWS because both of these things are, having to do with physical locations or servers. Encryption at all layers, that's definitely on the customer. And customer data, also on the customer. So we're going to go with the last two there. All right, so again, we have the shared responsibility model, and as you can see, we have customer data here and the customer responsibility area, and we got client-side encryption, server-side encryption, and then encryption and traffic, also responsibility of the customer. So there we go, there's that. All right, moving on. Which of the following is not one of the pillars of the well-architected framework? So security is very important to AWS. So that's definitely one of the pillars. Cost optimization, also one of the pillars. And so is reliability. Redundancy is not a thing. So that's going to be our answer there. And if you come here, we can see there's actually, just so you're kind of aware. Traditionally, there's been 5, but they just added a 6th recently, which is sustainability. And basically, it means, saving the planet. They don't really ask you much about this because it's relatively new and there's not, a ton of, I don't want to say value in it yet. There is value, but from like a technical and business value standpoint, there's not yet. This is more of a tenant for AWS. So that one's slightly less important, but you can see there's a few others here that the other 5 that have always been around for AWS that are definitely important and very applicable. So there's those, and as you can see, security, reliability, and performance efficiency are there, and so is cost optimization. But redundancy is not here, so that is not correct. All right. How does AWS define cloud computing? The term used when describing virtual machines, a secured set of servers a company can pay to own from AWS, the on-demand delivery of IT resources over the internet with pay-as-you-go pricing, a pool of on-premise servers a company can configure to provide a virtual network. That one's pretty clear here. It's going to be the on-demand. It's even got buzzwords, right? The on-demand delivery of IT resources with pay-as-you-go pricing. That's got AWS written all over it. And additionally, cloud computing does not have anything to do with on-premise. So that one's not correct. And then you're not paying to own anything. It's always going to be AWS's. You're just going to use it for as long as you need it. And then this is just virtualization. This is not cloud computing. All right, so yep, there we go. And then here's a little blurb about from AWS about what cloud computing actually is. And as you can see here, the on-demand delivery of IT resources over the internet, pay-as-you-go pricing. So there's that. But if you're not super familiar of what cloud computing is or kind of what it does, this is going to be a helpful form here. And my goodness, look how dark it is now. Let me give me a second here to turn on some lights here. I'll be right back. All right, it's better. All right, where were we? So there's that. Next question, which AWS service can scan your environment and make recommendations by comparing the results with AWS best practices? Amazon Guard Duty. Amazon Guard Duty protects your accounts. It doesn't necessarily scan and make best practice recommendations. It just identifies malicious activity, so it's not that one. AWS Organizations allows you to group multiple accounts under one umbrella. Again, doesn't have to do with recommendations for best practices. CloudTrail, we already went over this one. It tracks API activity and user activity in your accounts. And finally, Trusted Advisor, this is going to be the one we're left with, and that is correct. Depending on what support plan you have, you get more or less Trusted Advisor scans. But there's actually 5 areas that it'll provide recommendations for, and that is cost optimization, performance, security, fault tolerance, and service limits. Service limits is basically like how many of a certain resource you can have in a certain region. So for example, I think you can only have like 20 or 30 EC2 instances within a given region, if I remember right. But there's more information on that in here in the Trusted Advisor blurb here. All right. So next question, the main difference between a security group and a NACL. As soon as we click here, it's going to reveal the answer. So again, this is going to be one of the questions where if you want to take a guess, go ahead and do it now. All right, so it's the main difference between a security group and a NACL. Before we even look at the answers, we know one of the main differences that AWS always talks about is that security groups are stateful and NACLs are stateless. NACLs protect at a network level, right? A network access control list, and security groups protect at the instance level. So that's kind of 2 of the main differences there. Let's see if those are in here. So security group is stateful, yep. Protects at instance level, yep. NACL stateless, protects at network level, yep, that looks good. And that's the correct answer. So security group is not stateless. So that's not correct. Security group is stateful, but it does not protect the network level, so that's incorrect. And again, security group is not stateless. So that's the correct answer there. And we got some documentation here, the differences between NACLs and security groups. So there's that. All right, who is responsible for enabling encryption on data that is being stored on AWS resources? Okay, so enabling encryption on data. So off the top of my head, I mean, managing encryption is on the customer. So that's really what I'm leaning towards. So not AWS, the AWS customer, that's what we're looking for. The end user, I mean, they don't do anything with encryption. They just use the application. And encryption is not enabled by default. I mean, you could technically have some of your resources unencrypted. Definitely not recommended, but it's possible. So we're going to go with the AWS customer, and yes, that is the answer. And we can, again, take a look at the shared responsibility model. So client side, server side, and network encryption, all under the customer's umbrella of responsibility. All right. Moving on. Which of the following best describes the principle of least privilege? We've already talked about this a few times, so this one shouldn't be too hard. Only giving user permissions they need to fulfill their job requirement, nothing more. Yep, that's it. Yep, we don't want to give anyone admin privileges. Just right off the bat. I mean, if we need to create a user, then we need to create a user, so it's not that one. And then ensuring the privileges you give a user are not shared with another user. Yeah, I mean, that's definitely recommended, but it's not the principle of least privilege, according to AWS. So, yep, give minimum permissions. You can prevent security breaches, accidental errors, and then, like maybe they make some changes to your resources that are used elsewhere, but they don't tell anyone because they don't know. I see that all the time. That prevents them from doing that by only giving them, the permissions they need. And here's a blurb from AWS about least privileged permissions, and some links to documentation for IAM, which is where you'll actually do that. All right. The ability to provision physical resources from AWS, such as virtual machines and data storage space, qualifies as which domain of cloud computing? All right, so infrastructure as a service, provision physical resources, such as virtual machines and data storage space. That's close, but I think because we are talking virtual machines and data storage space as well, not just like the physical servers themselves, we're going to need to go a step up. So software as a service, this one's not going to be correct, I don't believe, because software as a service is more like an application or software that's ready to go and be used wherever. Doesn't really have to do with like the resources you're actually using, so not that one. Function as a service, that's I wouldn't say that's correct here. That's not really a term actually that's used very commonly. And then platform as a service, it might be this one because platform as a service, if I remember right, includes like the infrastructure and the operating system that you're going to run on that. So that's the one I'm going to go with. Let's see here. Oh no, it's infrastructure as a service. All right, so let's see here. So IaaS, infrastructure as a service, allows you to pay for somebody else's physical servers, in this case AWS. So we shouldn't have ignored the keyword here, physical resources. By using their infrastructure, you eliminate the need to buy and set up your own. So let's see, PaaS allows you to, this is platform as a service, the one we chose. It allows you to focus on the deployment and management of your applications, abstracting away all the management of underlying infrastructure you need to do. It's similar to IaaS. The key difference is that with PaaS, you get the underlying infrastructure and you require middleware, etc., that you made to build your application. But the question was only asking about physical resources. So we kind of, by including like operating systems in our answer, we kind of talked ourselves out of the question. That's the way it goes. So pay attention to these keywords. Physical resources is going to be infrastructure. All right. And then you can see here we've got types of cloud computing. So IaaS, PaaS, and then SaaS. Okay. So there's that. And to be honest, that's a question that definitely trips me up too. IaaS and PaaS are indeed very similar, and I often get them confused, as you can see. All right. Which of the following is not a retrieval option for S3 Glacier storage? Well, I'm pretty confident standard, expedited, and bulk are indeed options. Same day, that's not a thing. The different way, so we're looking at same day here is the answer. The different types of Glacier retrieval storage really come down to two things: how fast you can get your data and what it's going to cost. Basically, the faster you get your data, the more it's going to cost, and you can kind of see here what each tier in terms of the time it takes to get your data, what each tier has. So expedited 1 to 5 minutes, standard 3 to 5 hours, and then bulk is 5 to 12 hours. So again, bulk's going to be the cheapest. Expedited is going to be the most expensive. So there's that. All right, which of the following AWS support options provides you access to a designated technical account manager, aka a TAM, that manages and monitors your AWS environment specifically? So it's definitely not basic because we know that's only email support about billing questions. Developer, that's not going to be it because developers really only recommend it for like testing and experimenting purposes. It's not going to really be utilized for kind of production workloads. There's no need to have a TAM, so that's not it. Business is a plan that you have access two TAMs, but you don't have a dedicated TAM for you, right? So there's a pool that you can draw from. So you might get, whoever. But with enterprise, you have someone who specifically is dedicated to your architecture, your use case, your services that you can use as your go-to resource for your AWS questions. So we're going to go with enterprise here. And that is correct. So, it's the most expensive for a reason. I mean, if you want to have someone who is, at your beck and call basically and knows what's going on with your architecture, then you're going to need enterprise. And if we just do a control, so designated technical account manager for the enterprise level, and then you have nothing for business, and then enterprise on-ramp, which is kind of like a scaled back version of enterprise. You got that pool. So I was actually incorrect about business having the pool. It's actually enterprise on-ramp, which is kind of confusing to me why they have these two split out. But I guess maybe you have a larger subset of resources you're using that are more profitable, so you need the much larger enterprise support package versus the on-ramp one. So there's that, but either way, it's just full-blown enterprise in and of itself is the one that has the TAM dedicated to you and you alone. All right, so next question. Some important functions your application uses are currently unavailable. You can't work around the problem and your business is significantly impacted. Which of the following severity levels does this fall under? So this one's actually going to be a little tricky for me as well because I don't really use AWS Support as much. But let's give it a go here. So the keywords here can't work around the problem and your business is significantly impacted. So general guidance is definitely not going to be the answer. System impaired. I don't believe that one is going to be correct because your business being significantly impacted is generally going to come down to some kind of production workload, right? Because your business is using production workload as kind of like its main environment. So production system down and impaired. Down means it is completely inaccessible, completely out of function. It's immediately, you need help right away. But impaired, it means that some things are messed up and it is impacting your business, but everything's not completely down and out of commission. So I'm going to go with production system impaired. Let's see what the correct oh no, it's production system down. Man, all right. So if we just look at the documentation here, severity levels, this is what you're going to need to look at. So production system impaired, important functions of your application are impaired or degraded, but production system down is where your business is significantly impacted. So if we kind of look at the keyword here, your business is significantly impacted. That does indeed relate to production system down. I mean, it's word for word here. Word for word here. So yeah, this would actually be production system down. So I was wrong. Hey, only 3 wrong so far. It's not too bad. Let's see if we can finish this out well. All right, so which of the following tasks can Amazon Guard Duty help you accomplish? Ensure all of your, well, first of all, let's remember what Guard Duty is. Guard Duty is a service to monitor your AWS accounts for malicious activity. That's kind of like the broad overview of it. So let's see what fits that. So ensure all of your AWS resources are up to compliance standards. Doesn't really have to do with compliance or your resources. It has to do with monitoring your accounts for malicious activity. So I don't think it's this one. Continually protect your applications running on AWS from DDoS attacks. This is actually AWS Shields specifically, so not that one. Continually monitor your AWS accounts for compromised accounts and other malicious activity. So yep, that's pretty much the definition of Guard Duty, so we're going with that. Protect your web applications from a variety of common web exploits. This is Web Application Firewall, WAF, so we're going with C here. Yep. So Guard Duty is a service to monitor your accounts from a high level And again, the way I like to think of guard duty is, there's like a guard dog outside of your outside of its doghouse. The doghouse being your AWS account, and the guard dog is protecting the doghouse. So that's kind of how I like to think about guard duty. So again, config and scan, and config is more going to be for that compliance aspect of things. Shield is for DDoS attacks, and then WAF is for web exploits. So there you go, and then documentation for each there. Just a few more here. We're getting close to the end. Which of the following would be reasons why you would use elastic block storage, EBS, for an EC2 instance instead of the ephemeral storage? So right away, I know that ephemeral storage is temporary, and if an instance is terminated, you lose all that storage, so that's kind of a big deal. And the way EBS is designed to work is you can take what's called volumes and attach them to different EC2 instances. You can take backups of them, which is pretty nice. So those are some things that I can kind of think of off the top of my head. Let's see what the options are. So EBS volumes can be detached from one instance and reattached to the other. That's definitely true, so we're going to select that one. EBS volumes store less data, so they're able to perform read and write ops faster. I wouldn't say they store less data, especially because you can scale up or down your EBS volumes depending on how much you need to store. Ephemeral storage data is lost when the instance is terminated, but EBS data will persist. That's definitely true, so I'm picking that one. You can take snapshots of ephemeral storage data, but you can't take EBS snapshots. You definitely can take EBS snapshots, and I don't believe you can take snapshots of ephemeral storage. You can really only take you can create an AMI, an Amazon Machine Image, of what your instance looks like. But because you would then have to take that AMI template and start a brand new instance with it, I'm pretty sure that the ephemeral storage does not come over. But either way, you for sure can take EBS snapshots. So we're going with A and C. All right. So yep, we have more information here on EBS volumes. Again, those are the block storage devices that were designed to specifically work with with EC2 instances. And then you got different volume types. Like I mentioned, you can scale your volumes up or down, or change them to be, more better purposed for like IOPS, which is kind of like input-output operations per second. So basically how fast your EBS volume can do stuff, or just general purpose. And then you can see you can scale up or down the volume size there. All right, so that's EBS. All right, we got 3 more here. Every instance launch in AWS must be assigned to a availability zone. Yep, that makes sense. Otherwise, how is AWS going to know where you actually want to put your instance? So we'll go with that. Auto-scaling group, nope, you don't have to use auto-scaling. Even though it's nice, it's not mandatory. Placement group, same thing. It's nice, but not mandatory. And then config rule, this doesn't really have to do with this question at all, because you definitely don't have to assign instances to a config rule. In fact, you assign config rules to an instance. What just happened there? Oops. So yeah, it needs to be in an availability zone. All right, and then if you want to look here, you can see where you can actually keep AWS resources, specifically EC2 resources, and it's talking about the AWS region or AZ in which they reside. So they do indeed, sorry about that, need an availability zone. All right, so that's that. And just more information about auto-scaling groups, placement groups. Again, they're important, but not necessary. What's the primary AWS service that utilizes edge locations? I mentioned this earlier. It's going to be CloudFront. CloudFormation allows you to build templates that let you define how your resources are going to look and lets you manage them. Direct Connect is that direct physical connection from your on-premise resource to the cloud, your cloud resources. And CloudTrail tracks, again, that API activity and your user activity. So we're going with CloudFront. And looks like I didn't select the answer there. That's a problem. That'll be fixed by the time you get here. But it is indeed CloudFront. So yeah, CloudFront is a caching service that lets you cache content for users at physical data centers known as edge locations. Yeah, basically that just lets them access content faster because it's physically located closer to them. And then the other two services that use edge locations, there's the global accelerator for DynamoDB and Route 53. So that's just a description there of those other services that we already kind of talked about. And then you can see more information about edge locations. And it says a site that CloudFront uses to cache copies of your content. So there's that. All right, last question. What is the base unit used as part of your AWS CloudFormation to allow you to specify your infrastructure as code and easily deploy and manage your resources? I already kind of mentioned this about 20 seconds ago, but there it is. Templates. Templates are what you use. These other three choices here are components of CloudFormation, but they're not the ones that allow you to specify, how your infrastructure is going to look when you deploy it, and then let you edit those to actually kind of keep it updated and manage it how you want to. So templates are the way. Got some documentation here on templates. You can look at sample templates. You can look at a bunch of different sample solutions. There's, if you come here, we got some documentation here as well. You would go to the HTML version generally, and there you go. So that's CloudFormation, and that a template is the base unit for CloudFormation. All right, so we made it to the end here, and hopefully you were able to do well. As you can see, there's 1,000 total points, so your total score to pass the exam needs to be 70 or above. My goal is to get you to be a little over-prepared so that you pass no problem, as opposed to just trying to get you to be just enough so you can potentially pass. We want there to be no doubt, all right? So, again, hopefully you were able to, nail the exam. Feel free to retake it and take the additional one, number 2 as well, to get more practice before your test day actually arrives, so you can walk in there feeling good with no doubts that you're going to pass and become certified. All right, so best of luck to you, and best of luck to you as well on your continued journey through cloud computing.